In this video, you will learn how to determine the hybridization of an atom in a molecule. So how do we determine the hybridization of an atom in a given molecule? Now, to do that, we need to count the number of atoms attached to that atom and then also count the number of lone pairs attached to it. And we just have to add them up. Then if the sum is 4, okay, so we count the number of atoms. You take note that we count the number of atoms, not the number of bonds. So if the sum of the number of atoms and number of lone pairs is equal to, and take note that we count the number of atoms, not the number of bonds. So we just have to add the number of atoms and the number of lone pairs. If the sum of the number of atoms and the number of lone pairs is equal to 4, then that means the hybridization of that atom is sp3. If it is equal to 3, then the hybridization is sp2. When it is equal to 2, then the hybridization is sp. If it is equal to 1, then it's probably hydrogen. So let's take a look at this example here. So what is the hybridization of carbon in this given molecule here? So we have this structure, a Lewis structure. So we count the number of atoms attached to carbon. So we have 1, 2, 3, 4. So there will be 4 atoms, plus we don't have lone pairs because all of the valence electrons of carbon are completely distributed to each of the atoms attached. And then we don't have, there would be 0 lone pairs. And the sum of this one is equal to 4. Therefore, the hybridization of this is sp3. How about this given structure here? What is the hybridization of carbon? So we count the number of atoms attached. So we have CH3, H, and this one. So this is counted as 1, CH2. And since all of the valence electrons of carbon are distributed to each of the atoms attached, so that means there is no lone pairs here. So the hybridization of this atom of carbon in this molecule is just 3. That's the number of atoms attached to it, plus 0 lone pairs, and that would equal to 3. Therefore, the hybridization of this is sp2. Alright, how about this one? What is the hybridization of oxygen in this molecule? So let's count the number of atoms attached to oxygen. So we only have carbon here, and then we have 2 lone pairs. So that would be 1 attached atom plus 2 lone pairs. So that this would give us a sum of 3. Therefore, the hybridization of oxygen in this molecule is sp2. How about this one? What is the hybridization of for oxygen in H3O+? So H3O+ is hydronium ion. So we need to draw its Lewis structure first. So that would be, we have plus here, so that will be outside oxygen, our central atom. Oxygen has 6 valence electrons. So, and we only have 3 hydrogens there. We'll be left with 1, 2, 3, 4, 5, and 6. Alright, so we count for the number of atoms attached to oxygen. So there are 3 hydrogen atoms plus 1 lone pair. So this would give us a total of, and this would give us a total of 4 groups, or the steric number. So therefore, the hybridization of oxygen in hydronium ion is sp3. And by the way, the sum of the atoms and lone pairs is called the steric number, or Sn, or the groups of atoms and lone pairs. What if we're given this structure? What is the hybridization of nitrogen atom in this molecule? So we count the number of atoms attached to nitrogen, and we have 3 atoms attached to it, plus we have 1 lone pair here. That would be equal to 4. Therefore, the hybridization of this is sp3. Now, what if we're asked for the hybridization of acetylene? So we need to write the formula for acetylene. Acetylene is, the chemical formula for acetylene is C2H2, and then we draw the Lewis structure for this one. So our central atom here is carbon. Carbon has 4 valence electrons and only 2 hydrogens attached. So we have 2 carbons here. So that would be a triple bond and then hydrogen. And again, take note that we are not counting the number of bonds, but we are counting the number of atoms attached to it, to the atom. Right, take note here that the carbon atom needs 1 more electron to form the 4 bonds with other carbon atoms here. With other carbon atoms and the hydrogen. So this would give us a total of 2 attached atoms and 0 lone pair. And this would give us the sum, which is equal to 2, or the steric number is equal to 2. Therefore, the hybridization of acetylene or ethene is sp, because the sum is equal to 2.